So in this video, we'll take a look at the answers to the homework for Module 8, dealing with bonds. Throughout the class lecture, we were working with a dealer and we had several bonds in the portfolio, and we sort of examined that and looked at how the bond dealer could hedge any risk. So in this case, what we wanted to do, we have the two bonds. We wanted to add a third bond position to his dealing book. And in this third position, he's long 12 million of a 15-year treasury bond with a coupon of 3.25%, currently priced at 93.475% of par. So basically what you had to do is rework the entire dealer's book, given those three bonds now. And then you want to find out how much of a 10-year treasury the overall book is now equivalent to. And from that point, you can figure out how you would fully hedge the book. You want to look at, well, what's his one-day VAR at 95%, using that same standard deviation that we used in class. And so then you could figure out, well, how much would he have to hedge, right? In the 10-year. So let me pull up the spreadsheet, the way this looks. So, we started off with these two bonds, right? And so you worked through that with us. But now we added the 15-year, 12 million long position. So here I've got settlement dates. I'm just using today's date. It doesn't matter which date you use, as long as your maturity date is 7 years out or 30 years out or 15 years out or 10 years out, right? So we've got our settlement dates, our maturity dates, coupon rate was given, midpoint price was given, frequency, I'm assuming two payments per year on the coupon. That's typical for corporate bonds, but in the US, basis code. And so I'm calculating the yield, just given the yield equation that we used in class. Then I added 1 basis point to that yield to come up with a new price, to recalculate the price. And so that's going to allow me to come up with the DV01, just subtracting the new price minus the old price to get the DV01. So I did this for the 15-year. We had done it together in class, using the video together in class. 7-year, 30-year was done together. So you added the 15-year in, and then what you can do is figure out the 10-year as well. This is our hedging instrument. So what we do here is figure out what is that 15-year equivalent to in terms of a 10-year, right? And that way we can come up with, this is our risk equivalent. We can then add the three positions now together to get the overall book risk equivalent. So it turns out in this case, the book is long, 9.5 million roughly, right? So we're long. And so to hedge, we would have to take a short position in the 10-year in that same amount. So next part says, okay, let's look at how do we determine the bond dealer's VAR? Well, we were given this 1.75% daily standard deviation. We calculate the upper and the lower bound, just like we did in class. Now, the current 10-year yield was given, right, or we calculated it over here, 3.95%. So what's the worst case yield? Well, the worst case yield, we'd actually be looking at the upper bound here, because since the book risk equivalent is long, right? The book is long overall. So if rates rise, prices will go down. And so our worst case scenario is if prices rise. So we look at the upper bound here, and that's where I think almost everybody in the class got stumped on this. And this really has to do with that inverse relationship when you're dealing with fixed income instruments. If rates go up, prices go down. So since we're long, we're concerned about the upper bound, not the lower bound. And so you could then calculate, the change from the current yield and express that in basis points. And then you'd come up with your one-day VAR with 95% confidence. You see here, we're taking that change in current yield in basis points, we're multiplying by the DV01 for the hedging instrument, divided by 100, and then finally multiplying by the book risk equivalent to get a one-day VAR of, 94, 671, 65, right? And that's how much we could lose with 95% confidence on a given day, right? Again, you could lose more than that. There's a 5% chance that you could lose more than that, but this at least gives us some sort of a handle on how much is at risk with some degree of certainty.